So sequences in series, or I guess we just call them sequences here. This is definitely nothing we've done this year. Again, another one of those things. But it's real quick. I noticed on the reference sheet that you have, the formulas are already there. So kind of like back when we talked about compound interest, all you have to do is be able to plug in the right numbers and you're done. Okay, the formula is given to you. You don't have to worry about that part. All right, I will explain the formula so you have an understanding of what it means, how it's written, how it's set up. Okay. So there are two formulas to look at, and each of these is in one of these examples. So example A, or the first example here on the left. We have the sequence 4, 8, 16, 32, 64. By the way, a sequence is basically a pattern of numbers, and the formulas dictate sort of how the pattern goes. So we're going to write a function for this geometric sequence. Now a geometric sequence is a sequence where you're multiplying values out each time. So you can see in this sequence, if you didn't tell already, each of these numbers, can I zoom in a little more here? Each of these numbers is going up by a multiple of 2, right? 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So its pattern is going up by a multiple. That's geometric. We'll come back to the second example later, but it says right arithmetic or arithmetic, some people say it as, sequence, function. And the difference in this sequence is that these values are adding values. So you can tell on this one that you're adding 5 each time. So that's the difference between geometric and arithmetic. Geometric is you're multiplying values to get each successive number, and arithmetic is adding. And their formulas go like this. For geometric, it's A of n equals, and this is what your reference sheet says, I'm just copying it down from that, A1 R and then n minus 1 power. So here's what all this means. A of n is just basically the nth term. So that means it could be like the 6th term, 7th term, 8th term, etc., etc. Okay, that's basically what our answer would be, the nth term. So let's say, for example, looking at our sequence, you notice how the 5th term is 64? That's denoted as A5 equals 64, right? Because A5, that means the 5th term is 64. So nth term. That's what you're looking for there. Okay? Now, A1, as you could probably, if you might want to guess, references the first term because it's A1, right? So that would mean whatever the first term in the sequence is. R is going to be our rate, okay, which is basically the number we're multiplying by each time. As you can see in this sequence, we're multiplying by 2, so that means our rate will be 2, but we'll get to that in a second. And then n kind of references back to the A of n. It's the number of term in that sequence, okay? So to explain it shortly, let's say I want to find the 7th term of the sequence, A7. I want to find what the 7th term is, right? I need to know what the first term is. Let's use this one, for example. The first term is 4. The R value, the rate that I'm going by, is 2, so I'm going to plug in 2 because I'm multiplying by 2 every time. And then my exponent would be 7 minus 1 because n, I'm looking for the 7th term, so I'm going to plug in 7 minus 1, which would be 6. Okay, you can just do 4 times 2 to the 6th power. Okay, so that's kind of how it works. Now let me go back and write the function out for this particular example. Okay, so for this particular example, I'm going to write y equals, if that's okay, unless it tells me specifically otherwise. Y equals, you could probably write A of n equals. I don't know how they would want it on the test. Okay, A of n equals or y equals would be just fine, I would think. Okay, A1, our first term, if you look at our sequence, our first term is 4, right? Our R value, which is how much we're multiplying by each time, as you can see, we're multiplying by 2 each time. And then n minus 1. Just say n minus 1. Okay, oops, not n minus n, n minus 1. And the reason for that is because we have to plug in the value for n. Okay, I think it's, I mean, you can write it y equals. I would probably leave it as A of n equals. We'll see how they do. Now, what is the 12th term in the sequence? That means you're just going to plug in 12. So if you want to know what the 12th term of the sequence is, you're going to do the 4 times 2 and then 12 minus 1 power. So if you simplify that, it's 4 times 2 to the 11th power. Just plug that in your calculator, see what you get. Okay, I don't have the answer on me right now. I know it's on your paper already. I'm not going to go through the calculator to get that. Okay. Arithmetic sequence is the same thing, okay, except the formula is a little different. The formula for the arithmetic is a of n, which again still means the nth term. So that could be the 5th term, 6th term, 7th term, whichever one you're looking for. It's a1 plus n minus 1 times d. So basically, it's pretty much the same thing, except instead of r, we're calling it d. D stands for common difference, but it's the same thing as r. It's how much you're adding by each time. A1 still means the first term. N still means its position in the sequence. So like if you want to find the 17th term, then you're going to plug in 17 for n. Okay? So for this function, I'll write it as y equals again. A1, our first term, as you can see from the sequence, is 11, right? Plus n minus 1, and then times d. Now d's are common difference, and as you can see, we're going up by 5 each time, so that would be 5 in this case. So there's your function. Now if you want to find the 25th term, all you got to do is plug in 25 for n. So 11 plus be 25 minus 1 times 5. Now again, you could simplify that a little bit. Y equals 11, because you know 25 minus 1 is 24, so you could just say 24 times 5. Either way, plug that in the calculator and get the number. So it's real simple. A lot of the information is already given to you. The first term, the pattern itself. You do kind of have to figure out the pattern. I think for those two examples, it was pretty obvious that you were multiplying by 2 in the first one, and you were adding 5 in the second one. Sometimes it's a little less obvious. All right, let me look at these examples too, because these are pretty much the same thing, but require just a little bit more work. Okay, so the 4th term of a sequence is 512. So here's what I do, okay? I imagine this, 4th term, okay? 1, 2, 3, oh, the 4th term is 512. Each term after the first is 4 times the previous. That means when I multiplied it by 4, right? And then I multiplied it by 4 again. And then I multiplied it by 4 again. And I eventually got 512 as the 4th term, right? Write a function for the sequence. Now the function, remember, this is, obviously since it's multiplying by 4, it's geometric. So that's going to be this formula, a of n, a1 r to the n minus 1. So I know that's the formula I'm using, because it says 4 times, that's my keyword. So multiplying, that's my clue that it's geometric. Okay? All right. So I already know the r value because it says 4 times, right? All I need to finish this function off, and you can leave it as a of n or you can write it as y equals. I don't think it's going to matter. Just pay attention to the question on the actual test, how it wants you to write it. But all I need is the first term. Okay, I'm going to leave n alone because I'm just writing a function here. Okay, I'm not trying to use it for anything right now. So how do I know what the first sequence is, or the first term? Here's a couple ways you can do this. What I would do is, well, since I know that multiplying by 4, as you can see here, gets me to where I need to go. What if I take 512 and divide it by 4 3 times? So 512 divided by 4, what is that? That would be the previous number to it, right? So 512 divided by 4 would be 128. So that would be this number here, right? And then I would take 128, divide it by 4, and it's 32. So I know that's this number here. And then I can take 32 and divide it by 4, and I get 8. So now I know what the first term in the sequence was. It was 8. Okay? There's another way you could do that. For example, let me just I'll show you, but that's how I would do it. So if you want to skip ahead a little bit, you can, if that made sense to you. This is a little bit trickier, but I know that the 4th term is 512. So I know 512 equals, I don't know what the first term is yet, remember, but I know it's 4, and then n, since 512 is the 4th term, n would be 4, right? So I know that if I use that information, I have this equation, 4 to the 3rd power. 512 equals A1, because I'm still trying to figure out what the first term is. I don't know what that is. But 4, as I know, because that's the pattern. And then 4 minus 1. I plugged in 4 here because 512 is the fourth term, right? Of course, when I said 4 minus 1, I knew it was 3, so that's why I wrote 3 here. And now 4 to the third power. What is 4 to the third power? 4 times 4 times 4. 64. So this is 512 equals A1 times 64. So you can divide by 64, and you'll get A1 equals whatever 512 divided by 64 is, which is 8. So you get the same thing. A1 equals 8. My first way of doing it was a little bit more of a, common sense kind of way, but this is the second way is a little bit more algebraic. However you want to do it, it's fine. Doesn't matter. We wrote the function either way. Okay. All right. So for example, the last example here, the fifth term in the sequence is 84. So again, you kind of set it up the same way. So I know that 1, 2, 3, 4, 5. The fifth term is 84. And I know each term after the first is 15 more than. So this means you're adding 15 each time. So that tells me this is an arithmetic sequence, which is the formula is a of n equals a1 plus n minus 1 times d. All right, so 15 more than, this is my common difference, so this is my d value. Okay, but again, I don't know what the first term is. I need to figure out what that is. So I can write my function out. Actually, I'm just going to go ahead and write this as y equals here, just because I've done it before. All I need to know is what that first term is. Now, if I know that the pattern was going up by 15 each time, right? So something plus 15 got me there, then plus 15 again got me there, plus 15 again got me there, plus 15 again got me there. I can work this backwards if I want to try and figure out what the first number was. So let's do that. Let's take 84 and let's subtract 15. 84 minus 15 is 69. And then 69 minus 15 is 54. And then 54 minus 15 is 39. And 39 minus 15 is 24. So there you go. Now you know the first number is 24. Okay? So just stick with that. I think it's probably easier that way. There's your function. You're done with that example. Okay? So let me see if there's anything else different here. No, I'll probably just do, I don't know. I'll do one of these. Write the function for the geometric sequence in number 1. So it's already telling us it's a geometric sequence. So I know it's the formula a of n equals a1 times r to the n minus 1 power. Again, all I need to know is what a1 is and what r is. A1, as you can see, it's 2. That's kind of given to us, right? And then now all I need is the r value. So what am I multiplying by? Because it says geometric, so it must mean I'm multiplying by something. It looks like I'm multiplying by 3 each time. So that would mean the r value is 3. So there you go. There's your function. Now if you want to find the 8th term, that would mean plug in 8 for n. So you would do 2 times 3 to the 8 minus 1 power, which is the same thing as 2 times 3 to the 7th power. Whatever you get in the calculator, there's your answer for part B. Okay? So just make sure you use your formula. The formula's there. It's pretty straightforward how to just kind of plug in and use it. Okay? I'm going to end the video, guys, there. I think that was helpful enough. If you have any other questions, please do stop me in class and ask. I'd be happy to help. All right? See you later. Bye-bye.